Let's solve a set theory problem where we need to express a set in roster form. The set we're looking at is the set of natural numbers x, where x cubed is greater than 25 and x to the fourth power is less than 264. To solve this, we need to check natural numbers to see which ones satisfy both conditions. Let's create a table to organize our work. Let's start with x equals 1. 1 cubed is 1, which is not greater than 25. 1 to the fourth is also 1, which is less than 264. However, since 1 cubed isn't greater than 25, 1 is not in our set. Next, let's try x equals 2. 2 cubed is 8, which is still not greater than 25. 2 to the fourth is 16, which is less than 264. But since 2 cubed isn't greater than 25, 2 is not in our set either. For x equals 3, 3 cubed is 27, which is greater than 25. 3 to the fourth is 81, which is less than 264. Since both conditions are satisfied, 3 is in our set. Let's check x equals 4. 4 cubed is 64, which is greater than 25. 4 to the fourth is 256, which is less than 264. Both conditions are met, so 4 is also in our set. Finally, let's try x equals 5. 5 cubed is 125, which is greater than 25. However, 5 to the fourth is 625, which is greater than 264. Therefore, 5 is not in our set. We don't need to check any more numbers because we can see that for x equals 5, x to the fourth is already too large. Any number larger than 5 would give an even larger fourth power. Therefore, we can express our set in roster form as the set containing 3 and 4. Let's verify this makes sense. These are the natural numbers whose cubes are greater than 25 and whose fourth powers are less than 264. Both 3 and 4 satisfy these conditions, and we've shown that no other natural numbers do.